Hello everyone. Today let's solve the problem number 40, combination sum 2. Right? So what the question states here, given a collection of candidates and the target number target, find all the unique combinations and candidates where candidate numbers sum to target. Given a collection of candidates, you can clearly see here collection of candidate numbers. This is nothing but the candidate numbers, right? Given within the array 10, 1, 2, 7, 6, 1, 5, and the target which is of the type integer. So see here this one as well, right? So integer target we have been given. We have to find all the unique combinations and candidates where the candidate numbers sum to the target. See here 7 plus 1 will sum to the target, right? 6 plus 2 will sum to the target, right? 7 plus 1, 6 plus 2. Here one more thing, 125 will sum to the target, 116 will sum to the target, right? So these this one we have to find all the unique combinations and candidates where the candidate numbers sum to the target, right? So here see these are the numbers that sum to the target. Basically these are the combination of the numbers that sum to the target: 116, 125, 17 and 26, right? So same goes with example 2 as well. See here, target we have been given 5. So 2 to 1 will lead to 5 and 5 will also lead to 5. An individual number 5 is equivalent to 5. So these are the two numbers basically, right? So they have given us wonderful examples just for the sake of understanding, man. Let's do one thing. Let's discuss the approach first, followed by the complexities, and then let's write the code, right? So then let's write the code. So first thing I want to tell you here is we will be going with a backtrack approach, man, right? So just give me a second, 1 second here. Yeah, we will be going with the 1 second, just 1 second, ma'am. Yeah, we will be going with a backtracking basically. Just keep this in mind, right? So we'll be going with the backtracking. I'll be showing step by step how we will be solving this problem using backtracking, right? So the first step is let's consider the first example, the same first example here, right? So that we have already discussed this one. It will be easier for us to solve the problem, right? So you can just implement the same thing for the example 2 as well. First we sort the array, right? So first we sort the array. We have been given here 10 1 this one, right? So we'll sort the array in the ascending order. So this becomes 1 2 sorry, 1 we have twice, right? So double 1 2 5 6 7 and 10, right? So uh sorry, 1 second, 7 10, right? So when we sort the array we get on this order basically. So this is also 1 basically, so don't get confused, this is 1, this is fine. So 1 1 2 5 6 7 10 when we sort the array in the ascending order. So then what we will do, we will iterate from the start to end. Each recursion call moves start forward, so each number is used at most once. So we will be going with a backtracking approach. Just keep this in mind, right? So we will iterate from start to end. Each recursion call moves this one start forward, so each number is used at most once, right? So let's duplicate the skipping, right? So we can just go with the if condition. If I greater than start and array of I equivalent to array of I minus 1, then we can just give continue in the form of code, right? So let's see that one later. Just remember we will be duplicate skipping basically, right? So why we are skipping, basically we have to skip the same value at the same recursion depth to avoid the duplicate combinations. Means here we have got 1 to 5 here, right? So we can get the output 5. There are different permutations for this. This can be 5 to 1 and this can be 2 5 1 as well, so which will lead to the same output, right? So we have to uh, either consider any one of them, right? So any one of them, first combination that we get, will be considering that itself, right? So we'll not be considering this one. So that is the reason basically we have to we have to go with the duplicate skipping method, right? So we have to skip the same value at the same recursion depth to avoid the duplicate combinations, right? Then we will be going with the pruning. Then we'll be going with the pruning because array is sorted here. So we can just go with the array of I greater than the remaining target, right? So then we can break the loop. Then we can break the loop, right? So here first what we will do, we will go with the start equals 0, target equals 8, temporary variable will be considering that will be empty, right? So first this one I equals 0, we will be going with the array of 0 equals 1, the first number. We have got the sorted array right here. So I equals 0, we will pick array of 0 equals 1 here, right? So temp will be 1 as well. Temp will be 1 as well. So new target will be 7 because we have the target 8 here, and we have target value we have got as this one, array of 0 is 1, so we have to go with the 7, right? So we will recurse, call start equals 1, target equals 7, temp equals 1, right? So next step would be start equals 1, target equals 7, temp equals same thing when I equals 1, right? So again we'll be going with the temp 1 comma 1. Next we have this one, so let's consider this one as 1 comma 1. Let's this one, just ignore the temporary variable part. So I'll just write this one, what do we call, uh, the value basically. So or let's consider only temporary variable values itself. Here we have considered 1 comma 1. Suppose let me delete this one here. So this one, let me write on this format. So first element we considered, then target is 8, then we considered this one, right? So 1 comma 1. So new target becomes 6. New, so we are left with 6 because 1 plus 1 is 2. New target becomes 6. Next we will go with I equals 2. So I equals 0 we saw for this one, I equals 1 for this one, right? I equals 2, we will pick 2, the next number, right? So we have already picked this one, we will pick 2, right? So now this will be 1 comma 1 comma 2. Now this will be 1 comma 1 comma 2, right? So this is fine, 1 comma 1 comma 2, and target becomes 4 because we are when we sum up this one we get 2 plus 1 is 4. Target is 8, so the target is 4. Again we will recurse, right? We will recurse, call nothing but start equals 3, target equals 4, temp 112, right? So then we will go with I equals 3. I equals 3, we will pick 5, right? We will pick 5. So if I give 5 here, 5 6 7 8 9, it becomes 9, right? It becomes 9 here, right? So what we will do, we will ignore this part, what do we call, the considering two parts. So we will go with 5 comma 1 comma 1, right? So 5 comma 1 comma 1, right? So target is 1 now. Again we will recurse, right? Again we will recurse. So now we will be back to start equals to temp equals 1 comma 1, right? So now we will go with I equals 4. I equals 4, we will pick 6. We will pick 6. So now this will be again 1 comma 1 comma 6. This becomes 1 comma 1 comma 6, and target 0. Here target becomes 0. So we have found this one, right? So the first one will be 116. First one will be 116. So let me write here 116 at the top. So one combination we have found, right? So through the backtracking and the nothing but the recursive backtracking here, right? So the next one here is we will be going with I equals 5. I equals 5, nothing but here 7 is greater than 6, so we will break, we will end this branch basically, nothing but we have to backtrack to the previous level, right? So let's go with the next step here. So again, after finishing I equals 1, branch I equals 2, we will pick 2 man. This time it will be, instead of 1 comma 1, this will be 1 comma 2. This will be 1 comma 2, right? So target becomes 5, we will recurse. So I equals, next we will consider I equals 3, we will pick 5. We will pick 5 because we have considered 1 2 for the backtracking. We will pick 5, the next number is 5 here, so we will pick 5. This will be 1 comma 2 comma 5. 1 comma 2 comma 5, target becomes 0. Target becomes 0 because when we sum up this one, 5 6 7 8, so this is equivalent to the target, so target becomes 0. We have found this one, we will go with this combination as well, 1 2 5. So first one we have already went with 116, now we have went with 1 2 5. See here, this one, let me write it over here, 1 comma 2 comma 5, right? So this is fine. So I equals 4 we will consider, but we have to consider 6 in this case, right? 1 2 6, this becomes 6 plus 2 7 8, 8 plus 1 9. So 9 is greater than target, so we will stop there itself, right? So we'll stop there itself, right? So now let's continue backtracking, right? So we'll continue with I equals 3. I equals 3, we will pick 5, means now 1 comma 1 we have considered, 1 comma 2 we have considered. Now this combination we have considered already, 1 1 2, means 1 comma 1 and 1 comma 2. Now we will be going with a 1 comma 5 actually. right? So 1 comma 5 is the next number, right? So we will consider 1 comma 5. So when we consider 1 comma 5, we will be left with a target 2, because when we sum up this one, 5 plus 1 becomes 6, we this one target becomes 2, right? So what we will do, uh, uh, when I equals 1, we will branch this one. When I equals 1 branch means finishing I equals 1 branch, we will be picking 2 basically, nothing but I equals 2. So temp becomes 1 comma 2, right? So here, did I miss something? So we are considering 1 comma 5 here, right? Just give me a second here. Yeah. So this one we have already considered, man. One. Let's move on with the 1 comma 5 actually. Sorry, I got confused here. So temp we have 1 comma 5. Target is 2. Let's recurse. We have found no valid further, right? So basically 6 is greater than 2, right? So let's backtrack here. So when I equals 4, let's pick 6. Next, let's go with 1 comma 6, nothing but the next number in the array, right? Sorted array. So we'll be going with a, so this one 1 comma 5 will not give us any valid combinations, you can just check. So next we'll be going with a I 1 comma 6, basically target 1. So again we will recurse, no valid path will be found for 1 comma 5. For 1 comma 1 we found actually 1 comma 1 comma 6, right? So when we considered that one, 1 comma 1 comma 6 actually, and for 1 comma 2 comma 5 also we checked, right? So for that one also we got 1 comma 1 we got, 1 comma 2 we got, nothing but 1 comma 1 comma 6 and 1 comma 2 comma 5. So 1 comma 5 we recursed, we didn't get any valid combination. Here also for 1 comma 6 also we didn't get. So now we have, let's move with the next number along with the 1. This will be 1 comma 7, right? So 1 comma 7. So this combination itself gives us 8. When we sum up this one, 7 plus 1, we get 8 basically, right? So we get 8 here. So this one, let me give here 1 comma 8 basically. We have found the valid combination that is equivalent to the target becomes 0 here. So again 1 comma 7, 1 comma 7 we will be adding this one, right? We'll be adding this one as well. Next what we will do, we will go with I equals 6. I equals this one, what do we call, yeah, I equals 6, nothing but 1 comma 10. We will be considering 1 comma 10. Summing up these two itself will give us 11, right? So target we have been 8. So when we will not get any valid combination, so we will discard this one, right? Now again what we will do, we have to go with the this one, again we have to start, right? So from the top level, so I equals 1, array equals array of 1 equals 1, but I greater than start, and array of 1 equals array of 0. We have to skip this one because uh, we can produce the same combinations, means here the whatever the answer that we got here, we can get the same answer with different permutations, means here it can be 611 or it can be this one 161, but we'll get the same answer, right? So we will be skipping this part. So only one thing, so we will carry on with the same steps, we'll carry on with the same steps, right? So same thing we'll do with the 2 2 and 1. So 2 and 1 we have already considered here, 1 and 2, this is same as 2 and 1 is same as 1 and 2, like that we will go on backtracking, right? So we'll go with the recursion until we will be going with the recursion every step, we will recurse basically until we get target equals 0, right? When we consider 2, 2 along with the 6 actually, 2 along with the 6, this also gives us 8. When we consider 2 along with the 6, this also gives 8, right? So I have not showed any other steps because with 1 I have already showed every step, 1 comma 1, 1 comma 2. So 1 comma this one 1 comma 1, 1 comma 2 is fine. When we sorted the array, then we went with 1 comma 5, it didn't give anything. Then we went with 1 comma 6, it didn't give anything as well. 1 comma 7 directly we got, because summing up 1 comma 7 gave us 8. So 1 comma 10, it is already greater than, when we sum up it is already greater than the target, so that also didn't yield to this one target, that also didn't give any combination, right? The combinations that gave us correct output are 1 comma 1, 1 comma 2, and this one 1 comma 7, right? 1 comma 2 along with the 5, 1 comma 1 along with the 6, and 1 comma 7. That's it, right? So these three things we have considered. When we consider 2, the same steps will carry on, but when we consider 2, 6 along with the 2, we get 8. When we consider 6 along with the 8, 6 along with the 2, we get the same answer. So we will be adding that 6 comma 2. Every other combination fails. 2 comma 1 we have already considered, right? So 2 comma this one 5, that will lead to 7, right? This one, and 2 comma 5 comma 1 we have already considered. This one, see here, 1 comma 2 comma 5, that one also we reject. So we go on backtracking, right? So we go on with the recursion basically every step, right? So if we get the same valid combination, but we have already considered with a different permutation, then we will discard that one, as I've said this one multiple times, right? So this is the only thing that we get, 2 comma 6. And so the output that we got here is this one, right? So 1 comma 1 comma 6, 1 comma 2 comma 5, 1 comma 8, and finally 2 comma 6. The output that we got here is equivalent to the output that they have shown for the example 1 within the question, right? So example 1 within the question, right? So our approach works absolutely correct in this case. Our approach works absolutely correct in this case, right? So here now, as we are completely familiar with the approach, let's do one thing. Let's move on with the this one, what do we call, let's move on with the complexities part. So what will be the time complexity here? One second, man, just 1 second. Yeah, basically, sorry, I just had to drink water. 1 second, man. Yeah, this is fine. Now, the overall time complexity would lead to big O of 2 to the power of n. So why it is 2 to the power of n? So this is worst case. So in the worst case, the time complexity would lead to big O of 2n, because we have to explore all the subsets, right? So, but pruning reduces the runtime a bit. So overall time complexity would lead to big O of 2 to the power of n. So this will be the time complexity. So what will be the space complexity, man? Here, the space complexity would lead to big O of n, big O of n, right? Recursion depth. So the space complexity would lead to big O of n, uh, because we are going with a backtracking. Backtracking uses recursion. Recursion depth may recursion depth might go up to big O of n. We know this one. Recursion depth is big O of n in the worst case, right? So here in this case, the time complexity would be big O of 2 to the power of n, and the space complexity would be big O of this one n, right? So the time complexity and the space complexity for the code that we'll be writing in the future would be big O of 2 to the power of n and big O of n respectively, right? So now, as we are completely familiar with the approach and the complexities part, we are good to write the code. Let's start writing the code. Let's start writing the code, right? So first step here would be, uh, we have to store the final results, right, somewhere. So I'll be making use of the array list for it, man, right? So I'll just go with list here, list of, again, list. So within this, let me give integer as well. This is fine. Let me close the bracket here, angle bracket. So let me give here result equals new array list, new array list. This is fine. Yep. Yeah, this is fine, man. Now let's do one thing. Let's go with the sorting. uh, Basically we have to handle the duplicates easily, right? So for handling the duplicates easily, we'll be going with the sorting, the same first step we saw in the approach, right? So by considering the first example, so I insist you to implement in the same way that I showed for the example one. I tried to say the same thing for every problem. Almost every problem I say this. I go with the approach. Most of the times I go with the first examples. If the first example itself is very easy, or if it's I feel, if I feel the first example is not that much understandable, so then only I'll go with the second or third example, right? So I say the same thing every time. Whenever I consider the first example for the approach, just try to implement the same thing via example 2 in the way that I showed you, or in your own way, or in your own intuitive way. If you understand in a different way, suppose while I see some video, or while I try to understand some things, I might understand it in a different way. Maybe my intuition is different, right? So I try to implement in the different way. So you can go in that way, or you can try to implement in the same way that I showed for you for the example too, right? So there will be many solutions for the particular problem. There can be many solutions for the particular solutions. Rarely you get a problem that can be implemented with only one this thing. So that has to be algorithmic specific. Even if it is algorithmic specific, you can make use of different data structures accordingly with the constraints, right? So I I try saying, I mean, I say the same thing for almost all the problems. Try to implement for the different examples that I show for the example one, right? So if I show for the example one, try to implement the same thing for the example two that I said or that I showed, right? So in the same way, or while understanding the problem, if you get any different approach, if you think that there is different approach, better approach, or in a different way you want to do, please do it, right? So don't blindly go with my approach itself, right? So that's what I wanted to say. So yeah, let's move on with the problem, right? So here, coding part. So the next step is, let's go with the sorting just to handle the duplicates easily. So I'll just go with here. Let me come here. Yeah, this is fine. I'll just give here arrays dot sort of what we need to sort, candidates, right? So I'll just come here, copy this one, paste it over here. Fine. So let's move on with the next step here. We have to go with the backtracking, right? So instead of writing here itself within the main method combination sum 2 here, I'll just go with the helper method backtrack, and then let's make use of it within the main function combination sum 2. So I'll just come here. Let me give private void. So this one will be backtrack. This is fine. So let me go with int here. This is fine. This will be array, comma, int here. This one will be target. This is also fine. Int here. This is start. This is also fine. Int here. So this will be sorry, int start. Start I have already considered, right? Start and target. So this one will be list of integer. So this has to be capital I, man. Just give me a second here. So this is actually temporary value. If you remember temp that we considered within the approach, right? So we have to perform backtrack, right? So let me go with, we have went with temporary variable here. This is fine, start as well as the target, and also we have to go with the result variable as well, right? The same thing, list here. Within list, this will be integer. So again, why this is capital? So this is fine, integer. Let me consider result variable, anything, answer, result. I'll just take res here. This is fine. The first step is accordingly with the so whatever we have discussed in the approach, let's try to implement the same thing within the backtrack method, right? So if target is 0, right? So if target is 0, then we have found the valid combination, right? So here, if target is 0, then we have found the this one valid combination. We have to add that one to the array list, right? So I'll just go with new. So this one will be array list, simple. This is right. So let me go with the temp variable, man. This is fine. Yep, we don't have to return anything yet, so I'll just give just the return keyword here. So let's move on with the iteration part here. So this one will be for I equals start. So this is also fine. I less than array length of the array. So this one will be I plus plus. This is also fine. So we have to skip the duplicates at the same level, right? So we have to skip the duplicates at the same level, right? So I'll just go with I greater than start. This I had said this one within the approach as well, but that was the theoretical part. Let's try to implement the same thing here, right? So in the form of code, or let's try to articulate the same thing in the form of code here. So this one will be array of I equals array of I minus 1 previous element, then we have to skip, right? Same thing, same value we have got, then we have to skip, right? The duplicates at the same level. So means two numbers having same thing, or if three numbers are same but different permutation, then we have to skip that one. So for skipping, I have just made use of the continue keyword. And let's go with one optimization technique as one optimization technique, nothing but so no point in continuing here, right? So if array of I is greater than target, right? So because see, one combination that we got was 1 comma 10, Suppose 1 comma 10, let's consider this one itself. Target is 8, so we have considered 1 comma 10. So we don't have to go with any combination itself right here, because 1 comma 10 itself will sum up to 11, which is greater than 8. So we are considering other numbers. If even if we consider other numbers, it will be waste of time, right? So we don't have to consider this one at all, right? So one thing here would be, let's articulate the same thing in the form of code. So if array of I or iterated value of the array, if it is greater than target, then we have to break, right? So break means then we have to stop, right? So I'll just go with array of I greater than target, then I'll just give break. This is fine. So let's choose the current number. This one will be temp dot add of iterated value of the array. This is also fine, man. So we are just choosing the current number. Next, let's move to the next index, means recursion. Recursion. Backtracking we are making use of. We have to recurse at any cost. Backtrack uses recursion, right? So this one I'm stressing so that we remember this one while asked in the interview, or while we are solving the lead code problems, or any this one code forces problem, anything. So when we are making use of the backtrack, or if you are trying to implement backtrack in any of your code base, right? So if we are making use of the backtrack, it is nothing but the recursion, right? Backtracking itself, it is completely based on the recursion itself, right? So here we will be going with the array comma target. So target minus array of uh, I plus 1. This one will be temp comma result. So this is fine, man. Yep. So we have to move to the next index. This is also fine. So let's undo the choice. Once we have to backtrack. For undoing the choice, I'll just go with the temp dot remove. So this will be temp dot size minus 1, right? Minus 1 means we are just undoing the choice, right? So nothing but backtrack. So this is fine, man. We are done with the backtracking part here. I think we don't have to implement anything further, right? So this is it. Let's make use of that backtrack helper method within the main function, nothing but the combination sum. I'll just copy the method here, backtrack. Let me paste it over here. So I have to pass the parameters, right? So what are the parameters here? Candidates. Let me copy this one and let me paste it over here. So candidates, so it has to lead to the target. So then we will be making use of the target as well, and we will be starting with the array of 0th index. So I'll just go with a 0 here, and we have to save the result in the array list. So I'll just go with new array list. So result means if we found the valid combination, nothing but when target becomes 0, we have found the valid combination that we have to save within the array list, right? So that's what a new array list. uh, Syntax this one, let me write this one completely. And finally we have to go with the result variable as well, right? So these are the things. Fine. Finally we have to return the result. We have to return the result, right? So final result, which consists of all the this one, all the what do we call combinations, all the correct combinations that lead to the target basically, right? So that is the reason we have returned result. So this is fine. We have to return result basically. This is fine. We are done with the coding part. Let me run this one. I hope this works, man. Let's see. So you can clearly see here the sample test cases are getting passed, means the code works absolutely correct here, right? So the code works absolutely correct here in this case. So it works for only sample test cases. Let me hit the submit button, man. I hope this works for all the test cases. Let's see. So here you can clearly see all the test cases are getting passed, means the code works absolutely correct for all the test cases, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.